Okay, so let's talk about using algebra tiles to solve some equations. Um, we'll start off with a pretty easy one, x plus 3 equals 5. There are a couple different ways that people show this. Sometimes they use an equal sign, or sometimes they use like a little chart like this, and then they'll put the x plus 3 on this side and the 5 on that side. But anyway, go ahead and start off. I'll give you a second, pause the video and go ahead and try to model this equation with your algebra tiles. So here's how it's going to look for me. See, and I'm probably not going to do the little t thing because I always end up running out of room. But I'm going to put x plus 3 on one side. And then 5 on the other. Okay, so there we've modeled x plus 3 equals 5. And from there, to solve the equation, as usual when you're trying to solve an equation, you're trying to get x by itself. And the rule is that you're allowed to do anything you like as long as you do the same thing to both sides of the equal sign. So if you wanted to multiply both sides by 2, you could do that, right? It wouldn't necessarily get you any closer to solving for x, but you could do it. Anyway, in this case, if we wanted to get x by itself, it's pretty clear that what we need to do is get rid of these 3 units. And there are a couple ways we could do that. We could do that with the takeaway model, which would literally just mean taking these 3 away, which we're allowed to do as long as we also take those 3 away. And then we see the solution x equals 2. Okay. So that's one way to do it. That would be the takeaway model. Okay. To do this, the other way we learned how to do subtraction is to add the opposite. And this is going to be more generalizable, whenever you're tackling just any kind of given equation. It's usually easier to think about adding the opposite versus taking away. So if I wanted to get x by itself, then I need to add the opposite of these 3 units. I need to get rid of them. So I do that by adding the opposite. So I add 3 red tiles, which I'm allowed to do on the left-hand side as long as I do the same thing on the right-hand side. Okay, and then 0 pairs cancel, right? So that 0 pair cancels, and so does that one, and so does that one. And on the right-hand side, the same thing, 0 pairs cancel, and we're left with x plus 2. So, so the nice thing about solving equations with algebra tiles is that it's totally just a physical thing, right? There's not really much to write down. In terms of our class, this presents a challenge, though, because it means that we have to figure out a way to write down the steps that we took. So basically, you're just going to have to draw out each step in the process. And the way that you do that is sort of open to your own kind of interpretation, right? As long as each step is kind of clearly shown. I'm okay with you kind of doing this however you like. Here's how I would do it. So if I were drawing this, I would start off by drawing x plus 3, of course. And I'm just going to say if the tiles are not shaded in, then they're positive. If they are shaded in, then they're negative, right? So right now I have x plus 3 on that side and 5 on the right side. That's step 1. Then I'm going to draw a line, right? Okay, so this kind of indicates that this is my step 1. This is just the original equation, right? So now step 2. Well, actually, I suppose I would do this. You can maybe use like a different colored ink or something like I'm about to do to indicate like the manipulation that you're going to do to it. If you were doing the takeaway model, then you would just circle what you want to take away, and then circle on the right hand side the same amount to take away. And then in the next step we have our solution, right? Because that's what we're left with after we take away. So this would say x equals 2. Oh, I should circle my answers because you're going to think that it's an algebra tile. No, but that's just my answer, x equals 2. So that would be how I would draw out the takeaway model. On this, if I were to draw out the adding the opposite model, it would look very similar. Let me get my tiles off the page so I have room to draw. So let's do x plus 3 equals 5 again. So again, I would start off drawing x plus 3 and then 5 on the other side. And if I were solving this by adding the opposite, then I would say, all right, I've got 3 positive tiles here. I need to add 3 negative tiles to cancel them off. And actually, in this case, it's kind of nice that I have a red pen, right? Okay, so there's my step 1. And then in step 2, you know, so obviously these things cancel. So then step 2 is just x equals 2. Okay. So that's that one, right? So that's x plus 3 equals 5. That was just a little one-step equation, right? Not too terrible, I don't think. Let's do another one. Okay. Let's do 2x minus 1 equals 5. Okay, so I'll give you a second, pause the video, see if you can solve this equation using algebra tiles. Okay, now here's my solution. 2x minus 1 equals 5. So I'm going to start off by drawing I've got 2x minus 1. So for the minus 1, I might indicate that it's a negative like that. And then I'm going to say this equals 5. Okay, so there's step 1. Now I want to get x by itself. So one thing that I need to get rid of is I need to get rid of this. I need to get rid of this negative unit right here. So I'm going to do that by adding a positive unit. Okay, which I'm allowed to do as long as I add a positive unit to that side as well, and maybe just to make it less confusing. Right, these are all positive units. I'm using the different colored ink to represent like sort of the next step in the process for me. These are positive x tiles. Okay, so there's step 1. And then step 2 would say, all right, so now I've got 2x equals, I've got 6 positive tiles now, right? They're all positive, so I'm not going to bother marking them positive. Okay, so 2x equals 6. Now, if you tried to solve this, you may have gotten stuck at this point, and you may have thought, well, what am I supposed to do now? Right? I need to get x by itself. I could move one of these x tiles over to the right-hand side by, say, adding a negative x. So if I add a negative x, those will cancel. Add a negative x over here. But then I haven't solved for x, right? I have a statement that says x equals 6 minus x. So I haven't achieved my goal of solving for x. But so here's how we take care of these at this point. So whenever you have multiple x's left over, what you try to do is split up the right-hand side equally between all of the x's that you have on the left, so that you have visually you have a representation where you have an equal number of units for each x that you have on the other side of the equation. So so here's how that would look. So I would say, instead of arranging my units in a row 6 across, if I split it into 2, I would arrange it into 2 rows of 3. This is the same as the previous step, right? It still says 2 equals 6, or sorry, 2x equals 6, but it has the benefit of being very clear visually that x must be 3 then, right? So x must be 3. Okay, so there's 2x minus 1 equals 5. So that's a two-step problem, right? So we did an example, we did x plus 3 equals 5, which was a one-step problem. Here's a two-step problem. Let's see if we can make it a little more challenging. Okay, so let's do 2x plus 1 equals 5 plus x. Okay, go ahead and give the video a pause and see if you can work this one out. Here's my solution. Okay, so this is what it would look like initially. 2x plus 1 equals 5 plus x. And honestly, I'm going to solve it using, you could solve it by adding the opposite. I'm going to solve it by takeaway. I think takeaway is kind of easier here. You're welcome to do this using whichever method you like. But I'm going to say, I can take away a positive unit and take away a positive unit. Okay. So now my statement says 2x equals 4 plus x, right? Well, I can take away an x as well, right? So I can move this x and get rid of it. I can get rid of one of these guys. And now I've just got a statement that says x equals 4. Okay, you should get to the same place if you're adding the opposite, right? And it would look fairly similar, only instead of, taking stuff away, you would be adding on a negative unit, adding on a negative unit, adding on a negative x, adding on a negative x, right? And then the 0 pairs cancel, and you still end up at the same spot. You could also have done the steps in another order, right? So you could have gotten rid of the x's first in step 1, and then gotten rid of the units next in step 2. Anything goes, really. You could have ended up with the opposite statement, 4 equals x, right? Which still means the same thing, right? It's just written backwards, and that would have been fine as well. Okay, so that's that one. 2 more examples for you. Bear with me. let's do 3x minus 2 equals 4 minus x. Whoops, 3x minus 2 equals 4 minus x. Give the video a pause, see if you can work that one out. Okay, so I'm going to go ahead and give you my solution now. If you paused the video like you should have and tried to work this out on your own, then you probably got to a weird place where you end up with some kind of like fraction as your answer. And how do you represent that with algebra tiles? Well, truthfully, you can't really represent it with physical algebra tiles, but we can represent it, drawing algebra tiles as follows. So let's give ourselves 3x and negative 2. If the tiles are negative, I'm going to mark them negative. If they're positive, I'm just going to have positive tiles. Okay, so there I have 3x minus 2 equals 4 minus x. Here's where you have to be careful if you're trying to do the takeaway method, because you might be tempted to think, oh, I'm going to take away 2 tiles here and take away 2 tiles there. But if you do that, you're not taking away the same thing. On the left-hand side, you're taking away negative units. On the right-hand side, you'd be taking away positive units. That's not allowed, right? You have to take away the same kind of tile. So if you wanted to do this doing the takeaway model, then here you would have to give yourself a couple of 0 pairs so that you have some negative tiles that you can take away. As we've discussed in previous classes, a much easier way to do this is to just add the opposite, right? So I'm going to say, if I want to get rid of these 2 negative tiles, I'm going to add a couple of positive tiles. Okay? And I'm allowed to do that as long as I add on a couple of positive tiles on the right-hand side as well. So what do we have at this point? Well, these 0 pairs are going to cancel. And so now I've got 3x equals 6 minus x. Okay, so I'm almost done now. I just need to get this x over here. So I can do that by adding the opposite again, which I'm allowed to do as long as I do the same thing again on the right-hand side. So now I'm going to come back up here because I'm running out of space. Now I've got 4x Ooh, I'm not doing a very good job making these all the same size. But now I've got 4x equals 6. When I split up the 6's, I need to do so that there's an equal number of tiles over here for each of my bars. I've got 6 tiles, right? So I've got 6 tiles that I need to place, 6 unit tiles that I need to place. If I put 1 tile on each x, then that's 4 tiles. I need to place 2 more tiles such that they're evenly split between these 4 x's, right? So that tells me that I need to put on half a tile in each of these locations. So I'm just going to draw kind of like a skinny little bar and say that represents half a tile, right? So this is 1 and this is a half. And there's the answer, right? So any one of these copies of x is an answer to the equation. We would say x equals 1.5. Okay. So that's how we would represent that one. That's how you take care of these problems when, if there are any fractions in any of the, problems that you encounter in the homework or whatever. Okay, so let me give you one more example of solving a linear equation with algebra tiles. This one I might actually use the physical tiles on. So let's do 2 times 2x plus 1 minus 6 equals 3 minus 3x. Ooh, okay. Give you a second to work on that. Okay, so I'm going to start putting my solution up here. So in the first place, we haven't really talked about expressions like this and how to display expressions like this using algebra tiles. I think you'd probably be tempted to just distribute the 2 and say, well, it's 4x plus 2 minus 6. But you don't even have to do that much. If you just let the tiles do the work, right, and think about what this means 2 copies of 2x plus 1, right? So here's 1 copy of 2x plus 1. Here's another copy of 2x plus 1. Right? So I've got 2 copies of the same thing. Or maybe maybe an even nicer way to display that would be to say, like, there are my 2 copies of 2x plus 1, right? So here's 1 2x plus 1, here's 2 2x plus 1s, right? And so you don't even really need to think of 2. It's not necessary. You just put however many copies of this thing there are supposed to be. Okay, and then of course I still have minus 6 that I need to put on there. So 1, 2, 3, 4, 5, and 6. So there we go. There's the left-hand side. Okay, 2 times 2x plus 1 minus 6. Now we got to do the left-hand, or the right-hand side, sorry. So the right-hand side, we have to do 3 minus 3x. So there's 3 minus 3x. Okay. So this would be my first step. Okay, I'm not going to draw this one because I think you guys can probably, I think you've probably figured out a system for drawing this that you like. And if you haven't, then you need to give it some thought and work on it yourself rather than me spoon feeding you a system, right, for writing this down. But this is what we would have to start out with. So at this point, we can start solving the equation. One of the things that I would do right away is that when I see that I have the same sort of thing on both sides of the equal sign, I can get rid of those things, right? So like I can take away a couple of units from both sides, and that makes things easier. That already makes things look a little bit nicer. So this would be my step 2, right? So I would draw this out now and say, okay, so this is what I do after I did something, right? This is what I get after I did something. And so I would draw this out if I were doing this on like a test or something, or on the homework. Now for everything else, I think takeaway is going to be hard to use because I can't just take away a positive tile on the left and take away a negative tile on the right. That doesn't work, right? I have to take away the same thing on both sides. So I don't think takeaway is going to be the way to go. What I would rather do probably at this point, let's say that I'm trying to get rid of these unit tiles and move them over to the right-hand side. So I think what I would do is add the opposite. All right, so I'm going to add 6 positive tiles on the left, which I'm allowed to do as long as I add 6. So there's 2, 3, 4, 5, 6. Okay, so now I've got I've added 6 more tiles on the right. And now what's nice about this is the 0 pairs cancel, and that's going to cancel all of the unit tiles that were on the left-hand side. On the right-hand side, nothing else cancels. And I think I've got 7 now in total, right? 1, 2, 3, 4, 5, 6, 7. Okay, almost there. Probably the next thing I should do is move these X's over to the left-hand side, which I can do by, again, adding the opposite. So I'm going to add 3 positive tiles there to cancel the negatives. 1, 2, I'm running out of space, but 1, 2, 3. And then I can do the same thing on the left. Okay, and then again, 0 pairs cancel, right? And now I've almost got it, right? Now I have a statement that says 1, 2, 3, 4, 5, 6, 7x equals 1, 2, 3, 4, 5, 6, 7. If I just rearrange these tiles a little bit more nicely, let me put them together so it all fits on the screen. Then you can see pretty clearly, right? Each of these things match up. So we must have x equals 1. Okay. Kind of a boring solution, I guess. But there you go. X equals 1. Right? Each one of these copies is represents the solution to the equation. Okay, so that's that. Hope that helps.